The next topic is judging classifier performance for class target. Classifier here means a model that will classify an observation into a class. So class target instead of continuous or interval target. Interval, we already discussed interval target. So now we take the case of class target. So predictive performance of class target. So typically the actual value of the target will be either 0 or 1, in which case the target is a binary target. But it need not be binary target. If it's a categorical nominal target, can have more than 2 classes, okay, maybe 3 classes or 4 classes. Okay. But typically in usual situation, binary target is the most common target that we will encounter. So we will restrict our discussion to just binary target. So the actual value of y is going to be either 0 or 1. So it's not a continuous variable, it's not any value possible. So it's either 0 or 1. So the model that we will use for classification or classifier, as the previous slide indicated. So what that will do, that will give you is a predicted value of y hat, which will be a value between 0 and 1. So the actual value is either 0 or 1, but the predicted value will be a value between 0 and 1. And because it has all the properties of probability, that predicted y hat value can be used as a probability of belonging, of the observation belonging to class 1. Okay. So if a value is close to 0, so that means the probability that it belongs to class 1 is very small. But if a value is close to 1, then the probability that the observation belongs to class 1 is very strong. Now this probability is also called propensity. So propensity is the probability that the observation belongs to class equal to 1. Okay, and it is also called event. So the observation is an event. Okay, propensity is the probability that the observation is an event. So when you say event, that means class equal to 1. Then we can define the error term like we did before. So you take y, either 0 or 1, and then subtract the probability or the propensity, and that gives you an error. And once you have an error term, then you can compute all the fit statistics that we discussed previously. Okay. So now how do we use the propensity? The first step in most classification algorithm is to estimate the probability, okay, which are called propensities. Okay. And then the propensity is used in one or two ways. So to generate predicted class membership. So you can set a cutoff value, say default value is 0.5. So if propensity is 0.5 or more, then we will classify the observation as an event, that is class equal to 1. Okay. If the propensity is less than the cutoff value, then we will classify the observation as a non-event or class equal to 0. So that is one way of using the propensities. And the second way is similar to the lift chart that we talked about in the interval target. Here we want to rank order the observations from top to bottom in terms of probability of an event. So in descending order of propensity. So if this probability is, if the class equal to 1 is say bad credit, then we want to rank order ones who are really bad credit at the top and not a bad credit at the bottom. So we identify those applications which are really problematic, which will be at the top. We are really here the idea is not how well our propensities fit with the actual y equal to 0 or y equal to 1, but our interest is in rank ordering. So that would be the second way that we can use propensity.